Okay, this is a video of the problems on Henry's Law from chapter 11. Let's do the first problem. At 20 degrees, the concentration of dissolved oxygen in water exposed to gaseous oxygen at a partial pressure of 101.3 kilopascal. So my initial pressure is 101.3 kilopascal, or 760 torr. Is 1.38 times 10 to the minus 3 moles per liter. So my initial concentration is 1.38 times 10 to the minus 3 moles per liter. Use Henry's law to determine the solubility of oxygen when its partial pressure is 20.7 kilopascal, which is the approximate pressure of oxygen in Earth's atmosphere. So what about in pressure number 2, 20.7 kilopascal, or 155 torr? You could use either unit, the kilopascal or the torr. Just make sure that it's the same units. And we're asked to figure out what the new concentration is for that pressure. So we have a corresponding pressure and concentration, and we have a new pressure, and we're asked to find the concentration for that new pressure. We know that Henry's law tells us that the pressure and the concentration of the gas are directly related. So I can write this similar to what we saw for gases, similar to Charles's law with volume and temperature that were directly related. We can write it in the same way. So C1 over P1 is equal to C2 over P2. Okay? You can do this separately where you can use this formula. C1 is equal to K times P1, where you can find K is equal to C1 over P1. And because K is the same for both of these, you can then use the same K you find here to set it up for the second set of conditions. Or you can combine basically C2 is equal to K times P2, and then K is equal to C2 over P2. Well, these K's are the same, so I can set these two equal to each other, which is what I've done here. So you can do it this way, or you can do it that way. 2. I'm asked to find C2, so to isolate that, I cross multiply and I set the products equal to each other. My first cross multiplication is C1 times P2. C1 times P2 is equal to the next cross multiplication product, P1 times C2. To isolate C2 then, I divide both sides by P1. P1 cancels, so C2, let me rewrite it a little further down. C2 then is equal to C1, which is 1.38 times 10 to the minus 3 moles per liter, times C2, which is 20.7 kilopascal, divided by 101.3 kilopascal. My kilopascals will cancel, and then if I do this math, I will be left with 2.8 times 10 to the minus 4th moles per liter. and it's a unit of concentration because that's what I'm solving for. Now, let's double check our math to make sure that we've done it right. Because the concentration and the pressure are directly related, if I increase the pressure, the concentration will increase. If I decrease the pressure, the concentration will decrease. Remember, we talked about the example of the soda bottles or the example of the divers. With the increase in pressure, the concentration of the gas dissolved in the liquid also increases. So what are my conditions here? My initial conditions for pressure are higher than my final conditions. So P2 is lower than P1, which means that C2 should be lower than C1. And that is the case because I get a C2 of 2.8 times 10 to the minus 4th moles per liter. So I have done my math correctly. If you had flipped the pressures around, you would get a larger number, which would contradict what we know to be the relationship between pressure and concentration, so you could catch that mistake. Okay, this is the first problem. I will erase this and then we will work on the next one. Let's work on problem number 2. Exposing a 100 milliliter sample, so that's a volume. My volume is 100 milliliters. The sample of water at 0 degrees Celsius to an atmosphere containing a gaseous solute at 20.26 kilopascals. So my initial pressure is 20.26 kilopascals or 152 torr. Resulted in the dissolution of 1.45 times 10 to the minus 3 grams of solute. So my mass is equal to 1.45 times 10 to the minus 3 grams of solute. Use Henry's law to determine the solubility of this gaseous solute when its pressure is now 101.3 kilopascals or 760 torr. Okay, what do I know from Henry's law? From Henry's law, I know C1 over P1 is equal to C2 over P2. Now let's look at what we have here. We're asked to find C2. So what is C2? Concentration. What do we have? We have the initial pressure, we have the final pressure, and we're asked to find C2. But we don't directly have C1. What do we have for concentration? For concentration, we have a mass and we have a volume, so we can do a grams per liter type of concentration. So if I convert my volume to liters, divide this by 1,000, it will give me 0.1 liters. And to find C1, I divide my mass by the volume. Mass is 1.45 times 10 to the minus 3 grams divided by 0.1 liters. That gives me 1.45 times 10 to the minus 4 grams per liter. So that's my initial concentration. Now I have everything I need to find my second concentration. Once again, just like in that previous problem, we cross multiply and set the products equal to each other. This is my first cross multiplication. I have C1 times P2, and I set those equal to my second cross multiplication, which is P1 times C2. To isolate C2, I divide by P1 both sides. And now I can go ahead and C2, I can plug these numbers in. So C1 is 1.45 times 10 to the minus 4th grams per liter times P2, which is 101.3 kilopascal. You can use the torr as well, divided by 20.26 kilopascal. My kilopascals cancel, and C2 comes out to be 7.25 times 10 to the minus fourth grams per liter. That is my second concentration. Now let's double check our math to make sure that we've done it correctly. Because my pressure is increasing, I know that pressure and concentration of the gas dissolved are directly proportional. So if I increase the pressure, the concentration will increase. I'm increasing the pressure, my concentration is larger than the one that I started with, so I have done the math correctly. Once again, if you follow the logic of the law and you find that you have the wrong number, you probably just have flipped the pressure, the initial and final pressures around, so just flip them over. As you can see, most of these types of problems, you will have 3 out of 4 unknowns. In this case, for both problems, we needed to solve for C2, but you may need to solve for P2, you may need to solve for P1 or C1, depending on what the problem is. You have to be very careful on reading the problem and determining what you are given. If it's initial pressures and a final concentration, initial and final pressure and the initial final concentration, and you need to find the initial concentration, or if you're given the concentrations and the initial pressure and you're asked to find the final pressure, etc., etc. But you have to be very careful in reading the problem and determining the values that you're given, which condition it is, and what you are being asked. Okay, if you have any questions, please let me know. Don't hesitate to ask. Okay, thank you.